Anish, would you like to say who you are and what you do in the space?
So my name is Anish Mohammed. Who am I? I've been somebody who has been in the ecosystem for a long while. So I've been in the so-called electronic payment space for the last 2 decades. I started out building micropayments for Ericsson. I was based out of Stockholm in 2000. Then, in a brief while, I've been a researcher in cryptography. And since 2013, I've been very heavily involved in a blockchain ecosystem. So since October 2013, I've been an early advisor to Ripple. When Ethereum came out, Ethereum had Orange Paper. I was one of the reviewers of Orange Paper. Since then, I've been involved in designing or design reviewing half a dozen blockchain layer 0 layer 1 protocols and more than a dozen dApps. Mostly, I focus on protocol design and cryptoeconomics in that sense.
Oh, okay. So you've gone through a lot of that. That's like, a whole career over a really long time. So hopefully we can spend this interview like unraveling
Sure,
the intricacies of what you've experienced within the
sure,
space. So
absolutely.
it's always, I think, good to start from the very beginning, So you're from Kerala,
Yeah,
and you have a lot of projects that you're involved in, right? You're a
yeah,
doctor,
yeah,
cryptographer, amongst a host of other things. So you have many different hats that you wear
yeah,
within the
yeah.
space. So what do you think is at the heart of all the projects that you're involved with, like the many projects that you're involved with? What is it that you're trying to get at, do you think?
So I have a larger mental picture of the world, and my involvement in blockchain is also driven by that. I am one of the people who I would call myself an effective altruist, and not like a card carrying one, but effective altruism is this decision-making process. If you had two choices, choice A and choice B, you choose the choice that has more positive impact on humanity. So if you look at all the different projects that I work on, you probably notice I try to pick the projects that I can add the most value or the positive impact on humanity. So in a larger scheme of things, there are a whole subset of problems that I'm interested globally. And one of the problems that I was always interested in on the long run was this access to banking for the population of the world. So my first micropayment system was again a tick-based micropayment system with a client-side certificate. So you could think of it like a wallet almost, because if you have a browser wallet, you're pretty much doing the same thing now, 20 years after, right? And the thing about blockchain that really attracted me was the ability to attach policies to a data set. So without trusting anybody, you could actually make sure that when you hand over a bit of data, you agree to something that you agree to without trusting the party, for sure that policy is being adhered to. And that ability is kind of described as a smart contracts. And there are a whole bunch of other things that I'm really interested in, but in a very strict summary sense of speaking, is this ability to do trusting without trusting, and actually having policy attached to data that's allowing a whole bunch of governance to be done in a manner that was not seemingly possible before before blockchain was introduced. People might say you can use some of this thing already using trusted execution environment, but I would say to them that that implies you all have certain pieces of hardware with you, and you trust Intel and other people, and a whole bunch of conditional statements. You have much less of a conditional statement, much more of openness. Everybody can actually see. It does come with other challenges, like a challenge of privacy and things like that. And I have an interest in some of the bits that kind of solve this. So I've been involved in a startup that was doing zero knowledge proofs until earlier this year. So I have always been interested in this intersection where there is a bunch of problems in society that has actually been around, is becoming more and more relevant, and for society to actually operate in a fair manner, it is important that we solve some of these challenges. So the meta problem I typically describe is the information arbitrage problem. So, if you look at the world, the people who actually have access to certain information have the ability to change the world as it is. So you can look at UK, you can think about the Brexit election, right? Like Brexit election, not election, you know what I'm saying, right?
Yeah, yeah.
And elections in the UK, elections in the US. That was Cambridge Analytica using Facebook and creating an information arbitrage. And that kind of constrains how machine learning algorithms are allowed to run. And one of the things we actually require to actually do a fair and open society, where the society is very much driven by information, is the ability to actually enforce policies once the data is handed over. So it so happens that I've been one of the guys who have been involved in designing data marketplaces. I'm an advisor to Ocean Protocol, and I've designed a whole bunch of those things. So to me, that's the kind of problem that I'm after. I also have significant interest in ethics of AI. I'm a co-founder for EthicsNet. So for the last 7 years, I've been working with various entities, including IEEE, World Economic Forum, and people like that. So that's the meta constraint. And in the short run, it's just that it's a very interesting technology space. You get involved really early on. You really see how things evolve, and once you get involved, and you really see the possibility that blockchain could actually bring to the world. And I already see some of this becoming a reality. So if you look at CBDCs, that is a significant shift if you think about it. It's like somebody looking at you and saying, you know what, you guys are so good, I can't actually defeat you, so I'm going to join you. So to me, that is like complete acceptance of governments to the fact that blockchain and cryptocurrencies are not going to go away, and they're going to join the stream of people who work on blockchain to actually get the upside of the technology.
That's so interesting. And I like that how you start from this one simple question. It's like, what can I contribute to, making the world a better place? And then you kind of thought through it kind of logically to say like, okay, this is the most I can be effective. And it's interesting that you've posited it as kind of a, as many do, like as a trust problem, right? How can we enter into agreements with people while trust without having to trust them?
It's the differentiation thing for humans. So if you had read Humans by Yuval Harari, he describes how why monkeys couldn't build a civilization, right? Monkeys couldn't build a civilization because of the question of belief systems and trust, right? Right, and we all have a Dunbar limit, the number of people that we can actually talk to and keep a state of. What blockchain is effectively going to allow humans to do is to have a Dunbar limit of a larger set, and actually codify some of these belief systems, and translate that from the human world into a world, informational world, where this could be visible and shared, and people could actually describe how people behave, and let people be the judges of what's actually happening.
Interesting. And okay, some of these questions might be very obvious and you faced them before. So do you think there's a limit to that we can approach, or do you see it as an absolute problem or a limit problem, in the sense that there's only so much limit that we can get to, but we still have to trust humans a bit, right? And
yes and no. So there are different ways to think about it. You can think about it in a very meta level, or you can think about it in a very physical level. So if you think about it on a physical level, you always have human in the loop. Until the day that AI is completely capable of doing what they need to do, start to finish, without requiring a single human thought. Until that day, we still have to trust human. But the constructs of human typically means the trust have to be between the two people that are actually interacting then and there. So that could actually be delegated, and you can inherit trust. So when I say inherit trust, let's think about our conversation between you and me. So this is it's a transitional thing, or it's a delegation in one sense. So I have known Paul for the last 7-8 years, right? So when Paul sends me an email, says, Anish, I have Yatu, he's actually going to interview you. The trust between me and him is being translated, and effectively you inherit some of the characteristics of actually my interactions with him. And there's an update of the trust values on both sides of this equation when the kind of interaction is over. So this is literally happening in every day, in every life. And what is effectively happening is that the two different captured values of this is not visible to the public, and it's not really fairly shared. I can go away and say a bunch of lies about you, saying Yatu doesn't know what the hell he's talking about, or you can go away and say to Paul, Anish has no clue about this. I mean,
yeah.
both are valid statements we can make.
Yeah.
But how does Paul go about, of everybody outside this the current conversation go about validating this? Now that we are recording it, there's some evidence we have, right? And it's kind of what literally we are trusting. You're trusting me to actually provide you with the data that you implicitly trust. And what I'm saying here is that you are trusting Zoom, right? Instead of that, if you had a blockchain ecosystem and we had a smart contract, we do this encoding in live peer, we put it into Swarm, right? Given that I'm a member of a loosely speaking member of the team, I would love it to go on Swarm. Then what happens is, like, end of this conversation, we have a smart contract with points at this, and there's already people storing this thing, multiple copies of it, and it is censorship resistant. You have all the characteristics that you want straight away, and this is what it is. Like, it does all those things for you. We still have humans in the loop, but all the preconditions and postconditions have been taken away from the context and have been abstracted away completely.
Nice. That's a nice metaphor. I like it, and it's quite alluring. But yes, I think we could also problematize it, I guess. And I guess you'd be the first to, like, because you work in other things that kind of shine a light on this. That I guess is getting to that stage where of that infrastructure that you can trust, that can't be doctored or can't be manipulated, like so that that the Zoom call isn't doctored, so that, like, actually I'm said to say something that I didn't say, that someone's voiced over and sent to Paul, right?
This is what the start of the conversation was all about, right? You asked me why I'm interested in the problem. I talked to you about the ethics of AI. I didn't go into explainability of AI. If you think about a deep learning pipeline, and let's think about transfer learning in that sense, or generalized adversarial networks, right? Generalized adversarial networks actually has a generator and a discriminator. So imagine I take the video of this, right? Have a pipeline, have a pretty beefy machine with a GPU here. I have a machine learning pipeline running on my machines. I could take this, I could say to you, Yatu, I can actually get, upload this right now. I have some problem. And I, take this data, then I run my machine learning pipeline. Essentially, I have the generator data as the generated data set and the discriminator. Now, what a GAN does is actually creates the data, and the discriminator tries to discriminate it. Once the discriminator has been trained enough, then it is possible for me to actually make myself say what I want and record it as a Zoom video and send it to you. What you don't know is what is literally happening, right? So what is literally happening at that moment in time, if we actually were to trust blockchain, let's assume that to be the case. And we had this, this Zoom call being streamed to Lightpeer. Lightpeer encodes it. Lightpeer then dumps it back into Swarm. And, we actually had a smart contract which says we will have 10 copies of this file being kept for 1 year, right? Just making this up as I go along, just to give you some notion. And literally what happens is, like, the Square smart contract in Swarm would actually, make sure that our 10 copies has been there, and it actually makes sure people who actually have the copies of this are compensated for, doing this, right? And then you also know for a fact that the timestamp of that file actually has all your checksum. Essentially, it's not really a timestamp, because the timestamp happens when you actually don't have a cryptographic mechanism, right? This is actually a checksum. Literally says, this is the file that I entered. This is when they encoded it. So the people who actually have done the staking for encoding in Lightpeer are the trustees for you to say that what I said to you on Zoom is the file that you got encoded. Whereas if I just took the Zoom file, I did a GAN pipeline, and I did a whole fake thing, I could actually have the video I sent you could be absolutely different. I could be saying ridiculous rubbish things.
Yeah. Wow, that's so complex. Okay, so I mean, so what do you think is stopping us from resolving the trust problem?
Well, the trust problem is like, if you look at it like a building problem, right? If you look at a building, if you see a multi-story building, there is a part of it that you really don't see. It's called the piles, okay? So these are concrete structures that are driven to the ground until you hit the rock, the ground rock, okay? And sometimes what they do is, if it's really, really, places where there's mud, they drive in a lot more piles. And then you actually have a foundational layer of concrete, and then you have the building on top, right? So there is an underlying assumption that I was kind of describing at the start of the conversation when I said, Yuval Harari in Humans is kind of saying, Homo sapiens is kind of saying what it is. And in blockchain, that's cryptography. Okay? The cryptographic assumptions that you actually have that you never really see are the basis that you are taking for granted. And then there is this construct of a layer 0, layer 1 protocol that you have. And then there is this construct of a smart contract that somebody has. And then there is somebody thinking about something, which is what you rightly alluded to. Like, they have some construct in their mind, and they translate that construct into their mind into a logic, and the logic gets compiled by a language compiler into computational logic, and the computational logic runs. And we are kind of thinking what you and I are talking about, and we think about, if we write up 10 lines of solidity code, is what you and I are talking about is being implemented the right way. There are so many layers of failing that happens. So all the way down to the layer which is deep below, which is actually the cryptographic layer. The cryptographic layer has lots of complexity. The cryptographic layers, again, have layers of abstraction. Typically, all public key crypto actually has this very abstract number theoretic library called arbitrary precision number theoretic library, because all the computations that used in public key crypto require numbers that are very, very large. Typically, computers can do like 34 or 64 bit, right? That's the size of a number. But if you think about, say, RSA or ECDSA, ECDLP, you have like 160, 256 bits. That's the kind of size of one digit. So you need to construct a very large number out of a small number, okay? And that has to be really, really precise. If it's off by a very small margin, because of the way the cryptography works, it will never work, right? So you are completely trusting a whole bunch of things that you don't even see. And then there is this whole number theoretic representation in a CPU, right? If you take a CPU and you look at the CPU, what's effectively happening is you have things, instructions that's running there, and you're trusting all those things. And we also mentioned previously in a conversation about trusted execution environments, right? This is like a trusted platform module that's normally sat on a motherboard. And if you have such a trusted platform module, that actually sits in the hardware layer, literally, right? And it actually allows you to have certain characteristics of operations that of set of all operations that happen on a computer, right? So it will actually check whether the BIOS has been tampered with, if the operating system has been tampered with, the application that's running has been tampered with. So it actually, when it boots up, it checks the checksum for each of the different layers, and then it can actually enforce it. So I was saying there are two different models. So one model would be trusting Intel and trusting TPMs, and the latest version of that is called XDX, sealed glass. I can't remember what it's called, the last bit, right? So essentially, that's one end of the spectrum. The other end of the spectrum is a more decentralized one. We assume everybody has the same kind of stack. There are no, majority of malicious actors. So most of the consensus algorithms really require that you have at least a majority of, non-malicious actors. So that goes to, say, proof of stake in one sense, proof of work in that sense, and pretty much all the consensus algorithms. And consensus forms the basis for other things to be built on. and consensus kind of implies we have trust. So,
Mm-hmm.
given we believe that consensus is going to run in a particular
Mm-hmm.
manner, we know that the result will be fair, and hence our question of trust.
Mm. That's going through a lot of layers. I'm glad you gave the building analogy to think through that one. Yeah, that's interesting, and I was particularly interested. I didn't know about the requirement on knowing very large numbers to make
Oh,
something quite
absolutely.
creative. Yeah, that's quite
Yeah. So
interesting.
you have SHA-256 and
Yeah,
SHA-502, or whichever you choose.
yeah,
So that need to get mapped onto an elliptic curve point. An elliptic
yeah.
curve point is going to be the same size or bigger, so you can actually this
Mm-hmm.
can actually go in. So that means that number is even bigger, and the size of a normal integer or a float on
Mm-hmm.
a computer. That's up to like 64 bits. If you even have double, is 128, right?
Mm-hmm.
So even then, it doesn't really get to the size you want. So you need to construct an extraordinarily large number with very high precision. So if you have a single error, this is kind of what I'm referring to, that we are making so many layers of trust. In each layer
Yeah.
of trust, if and only if the conditions in the underlying layers are met. So we are assuming the files have been driven in the right order. We don't know. We only see the head of the file. We are trusting the file to say the people who drew the files that, okay, you can go and build a 100-floor building on top of this. Okay. And they are just telling you, you only have the ability to see the top of the file. You have no information other than that, but you need to trust them.
All these layers of trust, right? Mind to smart contract to kind of the theory and each of these things. And you've got your trusting developers and coders and cryptographers to kind of, build this layer of trust. But do you think there's also an element of time and people trying it out, right? I think I've heard you mention somewhere saying like a simulation can only get you so far, right? And it has to be ultimately tested out by people and and even technology can break that kind of trust as technology develops, right?
Yeah. So the reason I say this is like, this is not the first time I've been involved in technology. So I've been in technology in early on for multiple things. So I was involved in the cloud. So I'm one of the people who wrote the Cloud Security Alliance Guide, Cloud Bias Decision Guide, moving to the cloud, sat on the ISO committee, a whole bunch of things of that sort, right? So that's like starting from 2007, right? So you could probably find talks of mine about talking about cloud. Then in between, I was involved in open source drones. So I was a developer for Ardocopter. So you could probably see a lot of the talks I've given, newspaper articles about me being involved in drones. So this is, to me, like, it's a systematic thing that actually happens. Technology evolves in a particular manner.
Right.
And, you see patterns in technology, and the patterns are pretty much, how could I say, replicable. And in the case of blockchain, what has actually happened is, a lot of the technology has been around for much, much longer than what we think, right? If you think about the proof of work, which we briefly mentioned about consensus, right? It has been around for a very long period in time. What effectively Satoshi did, which actually shifted the paradigm, is literally the fact that he put all the Lego blocks together and make it all work in a particular manner, right? And what is happening in the blockchain ecosystem now is because of the other thing that I described, the cloud compute kind of situation, where the cost of actually putting up an infrastructure has come down significantly. You can turn up and do something silly and do a test, right? And if it works, it works, right? Your cost of actually experimenting has come down significantly. So there is a whole bunch of people who are looking at this and looking at various opportunities. I am not looking into the motivation for the people to do this, because there is this value transfer mechanism that's been attached to blockchain. What has been happening is, sometimes what happens is the meta objective of a set of people who are getting into this ecosystem is to capture some value out of this ecosystem really fast. So if you look between 2017 and like 2018, like end of 2018, there was actually 2016, for being very precise, there was a real boom for ICOs. This was like, somebody understanding the concept of tokenization. However, that is not really new. There were colored coins really ahead in 2014, and then in 2014 there was Ethereum 18 million being raised, and in 2016 they had the DAO, and it took off, and there were the legal arbitrage that was created by certain legal structures in Switzerland that allowed people to do certain things. And there was also the transference of trust, which was literally what we were talking about from the start, which is like, you have a smart contract represent an organization, and you as a user has a token that allows you as a user, when presented with this token to the smart contract, will allow you to have access to a service that's been described. So take Golem, right? Or take
Mm-hmm.
Ocean Protocol. If you had Ocean Protocol, if you have the Ocean token, what you have then access to is the access to the Ocean platform. Or
Mm-hmm.
take Swarm, which we were briefly describing. Then in Swarm, if you have this, the new token is coming. So once you have it, then you can have access to storage. So that's a utility that you can actually have access to. And literally in this so-called ICO phase, what literally
Mm-hmm.
happened is a failure of governance, right? So
Mm-hmm.
people set certain things, and smart contracts can't go into the real world. There is this
Mm-hmm.
cognitive dissonance between the decentralized world and the centralized world.
Yeah.
Physical beings live in a centralized world in one sense, and we were
Yeah.
describing about the Dunbar limit and things of that sort. And there is this, how could I say, a bridge that exists between the decentralized world and the centralized world. So
Mm-hmm.
when you want to do identity, you still need to give a proof of identity, and the proof of
Mm-hmm.
identity in all senses is data that you collect from the physical world, right?
Mm-hmm.
So literally what you need to then do is to map this from the decentralized world to a centralized world. And briefly in our conversation, I mentioned about the zero knowledge proofs. And that's
Mm-hmm.
the kind of technology that allow you to actually prove to somebody that your identity in the centralized world is valid for decentralized world and it's true, right? But
Mm-hmm.
still, all the problems still remain, right? So
Mm-hmm.
this real challenge of being able to enforce something that's actually being said in the decentralized world, in the centralized world, and the other way
Mm-hmm.
around, it is part of a problem we have in the blockchain, which actually costs in some sense, kind of a failure of governance and
Mm-hmm.
some ecosystem failures, right? So in one
Mm-hmm.
sense, you can see a real surge of innovation happening, and the
Mm-hmm.
other sense, because of the value capture that's happening in the cloud, you can't actually go capture value from people and disappear, right?
Yeah.
It's very expensive. The capex for actually doing that is pretty high. So cloud kind of subsidize, reduce the capex as the capital expenditure, and the opex is like tiny, right? So literally, what has happened is the real paradigm shift, which allowed capex to come down and opex to be very tiny, allowed people to stand up smart contracts, allowed people to run blockchain instances, and then run new projects. And some of them did very cool things, and a very large fraction of other people did other things, but
Mm-hmm.
the value add is really questionable.
Yeah. What are you working on around this problem, perhaps?
Prior to this, I was actually working on a protocol using zero knowledge proofs.
Mm-hmm.
So the whole idea was, markets are pretty much based on information arbitrage. If you want to have a fairer market, you need to reduce the information arbitrage. And there is this concept called zero knowledge proof
Mm-hmm.
systems, which is a very trivial thing. Imagine this room right now just has
Yeah.
one door. You can actually see the door. And
Yeah.
I am actually the prover. You are the verifier. Imagine
Mm-hmm.
you're around here and you just say to me,
Mm-hmm.
oh, prove this thing to me that you have the ability to escape from this room without using the door.
Mm-hmm.
So I come outside, I stand right next to you, I walk into the door, you close the door
Mm-hmm.
behind me,
Mm-hmm.
and then after 5 seconds, you see me outside. And you
Mm-hmm.
know that I didn't come through the door, right?
Yeah.
So the claim that I made is my ability to escape from the room without using the door. Okay,
Mm-hmm.
that's the claim. And the proof you have is I'm stood outside. What you
Mm-hmm.
don't know is how did I escape, right?
Mm-hmm.
So this is a zero knowledge proof. We can continue doing that until however many times you want, but you would
Mm-hmm.
have no extra information than the last time that how I
Mm-hmm.
escaped from the room. So this
Mm-hmm.
is called a zero knowledge proof. So when you prove there's an interaction between a prover and a verifier, where the
Mm-hmm.
prover actually proves to the verifier that the claim is true, the
Mm-hmm.
informational gain that the verifier gets is zero. That's how it's called a zero knowledge proof.
Nice. That's explanation of yeah. I think I find it quite fascinating. Zero knowledge proofs. I've seen. Well, I don't know if like a few coins centered around that. I guess
Yeah,
which is quite interesting. Yeah.
so initially it was an interactive thing. So effectively what this means is interactive, like you and I have to interact to do this.
Yeah.
So then there was a non-interactive one, and the non-interactive one was one of the first ones was in Zcash, which was a SNARK,
Yeah.
interactive argument of proof, right?
Mhm.
So now after that, what has happened is that required a setup. Essentially, the prover and the verifier need to be involved in some mathematical computation, and there's some
Mhm.
level of trust involved in saying the total number of people that are malicious in that trusted
Mhm.
setup process have to be bounded. But then there were later protocols that were created like Starks, which actually doesn't require this trusted setup. And there are a whole bunch of them. So there's Beam, there is Wimble, then
Yeah.
there's Zcash, there is Monero is not really zero knowledge. There's a bulletproof. It's kind of on the edge, so slight variant. So Snarks actually use elliptic curves. Starks use in one constructing of some of the problems in coding theory. Essentially, it's given a polynomial, how do you actually verify with actually the smallest number of interactions? That's what it is. So in coding theory, if you do apply error correction codes, you have the same problem.
Yeah.
So this is effectively being flipped around to actually prove something in zero knowledge in the Stark scheme. And there are like other schemes that are there, use variants of other things to prove this.
Interesting. Yeah. And Grin as well. I think Wimble, I've been following their projects. It seems quite interesting what they're trying to do, like the whole Beam Grin thing. Okay, cool. Right. So let's move on to something community-based, perhaps a more business orientated. So you're also have a position in Berlin, right?
Yeah.
Okay.
Head of research.
Actually, no. Yeah. We'll come back to that. But okay. So just to say, you've been in the space for a very long time. What can you in simple terms kind of map out how things have changed for you, or like what do you think have been like key moments that have like made you interested and be like, oh, that's a really important moment, or things in the community that have changed, or how do you think the vibe of the space has changed?
Given I've been a layer 0, layer 1 guy, I kind of look at the world with milestones in the protocol layer, right? And there are some extra bits that happen. So first thing that happened was when Bitcoin happened, there was like the first generation, right? So it had the ability to actually transfer value, right? That was, effectively the whole thing about Bitcoin was to prevent offline double spend. So the construct is very trivial. I have a wallet, I have some money. In a physical world, when I have a £10, right, in my wallet, this is actually, it has a statement by the issuer of this note that, whoever it's a bearer instrument. If I give it to you, my wallet have £10 less. In a digital sense, I can create a copy and I can send it to you, and I can send the same thing to Paul. I can send it to a lot of people, right? And you shouldn't allow that. Then actually breaks the value proposition, right?
Yeah.
Because you're able to create. So you need to prevent. You have to have this ability to actually just spend it once, but not being able to spend it twice. So this was solved by the construct of blockchain, right? And that's like the real innovation in Bitcoin. Now, what happened in Ethereum was, in addition to actually having a blockchain, you put an EVM, a virtual machine, on top, and you have the ability to run smart contracts, right? So this implies, as I was describing from the start, this ability to attach data to policy in that sense. So what does smart contract stand for? A smart contract doesn't have the ability to interact with the real world. You have to give it some data and you can make some decisions. Yes, you can interact with the real world using data, using an oracle, right? Say, for example, well-known oracles include Chainlink and other ones, right? So essentially that is an oracle. Oracle is a bridge in one sense. Remember, we were talking about the bridge between the decentralized and the centralized world. It is a bridge between the centralized and decentralized world. And you are trusting the oracle. The oracle is being trusted, right? So this is essentially happened. So that's, that was generation 1, then generation 2. And generation 2 had a lot of problems about throughput. So we were looking at various things. So then generation 3 came along. They were like scaling things. So, I didn't participate really that much in generation 1, but yes, if you consider Ripple a generation 1, I was involved in design of Ripple, and then Ethereum came around. for mostly on the Swarm side, I was involved in the design of Generation 2. When Generation 3 came along, I was involved in a couple. There was one called Dev.io. Essentially, there are a bunch of things that you try to do to actually make transactions really fast. So it's a bunch of scaling problems and a bunch of other problems that you actually wanted to actually solve, right? So scaling problem effectively is like rollups, zero knowledge rollups, Plasma, a whole bunch of things of lightning and things of that sort. That's actually happening in that sense, right? You want to actually improve the economic efficiency and improve the throughput. And that was to me like a Gen 3. And to me, a Gen 4 is kind of, you have more problems, like problems in privacy, problems, other kind of things that you need to have. So those are the kind of things that's actually getting solved on the long run. So the crypto economic problems of efficiency, the issues around data and privacy, this all become really getting entangled into the blockchain, and those need to be really solved to actually achieve an economy that can actually handle like 80 trillion or so many quadrillions of assets that are there in the markets. In that sense, you need to have the security margin that's high enough. You need to have the throughputs that are high enough to do the transaction. You also need to have the characteristics that allows us to have the same level of privacy we have with a piece of paper, right? So this is kind of the thing that I suspect is ecosystem is actually heading towards.
Interesting. And I guess it's nice the way that you put it at each stage as the problem scales, as the value transfer scales, when you're doing that between smaller community of 5 to 10 to you encounter new problems, and you've been at those problems at each milestone, right? And said like, okay, the first problem was this kind of problem emerged, and then this stage of the scaling, this problem emerged, and you kind of and I guess as you scale more and more and more, you encounter problems that maybe that people weren't even aware of that kind of starts coming about, right? So it's about kind of anticipating those problems, isn't it? And thinking about how you can. So I think you just mentioned this. You mentioned at the start, but just to clarify, like, what do you think the problem now is, like, in terms of scale where we are? What the problem that we're trying to forestall now,
absolutely,
and what the next stage might be, you think?
Okay, so I kind of mentioned this. So I've been saying that I've been doing some consulting. So with a couple of my team members, we wrote a piece about DeFi, and I kind of described this this problem in that piece I wrote about DeFi, in decentralized finance in that sense. Like literally, I broke it down to 3 problems. So first problem is like throughput, which I was describing prior, and I was describing solutions to that, right? So it is like a congested city. Like, back home in India, if you were to look at a city in like a 10 years time, that happens in China maybe in 3 years time. If you were to go take from one point in the town or one point in a city, say take Bangalore, like, probably 20 years ago, you could have gone from the Outer Ring Road into Brigade Road in like half an hour. And you only imagine there was an equivalent of an Uber there, and you used to pay an amount of money. The money you would pay would be significantly increased now for multiple reasons. One is congestion. So congestion essentially means you're stuck in traffic much higher, and also Uber and other people recognize the opportunity cost, and they do surge pricing. The same thing is happening in Ethereum. Okay, and this could be applied to any other ecosystem where there's this arbitrage possible. Then you want something to go through. You want to get to the front of the queue, and you're willing to pay something more. And in different parts of the world, we call it a bribe, right? And this part of the world is considered, it's a fair mechanism, okay? So that's one. And number 2, the thing that we described, and which is like a meta problem all around, is this governance problem. How do you actually map the rules that we agreed to upfront is actually being adhered to in the real world, right? So if you look at some of the DeFi protocols, there were like complete failures. Say, for example, Curve CEO used to be in the UK. He had a company called ZeroDB, and in theory, I was one of the advisors. I have a signed contract, so it's not in theory; it's in practice. I was an advisor to ZeroDB, and then he switched the name to NuCypher, and then now he runs a company called Curve, right? And he accidentally, changed the voting proposition on Curve that implied that all the investors had very little ability to influence the decision-making process. That is a governance problem, right? So imagine you build a protocol and you agree to a particular thing, and partway through this whole protocol thing, suddenly it so happens that you say, "Oh no, I'm sorry, I accidentally did this, and now all of this thing has changed," right? That is the difficulty with governance, and there is also the difficulty with transparency, because it's like, as we were describing previously, there's this map between the decentralized world and centralized world, where you prove to somebody who you are, and the connection between the two is kind of weak because there are no proofs actually being really tying things down. So, for example, if we actually had zero knowledge proofs to that, that'd be pretty interesting. Right now, it's kind of weak. So the set of all actors that are there behind this is not visible to everybody. And again, at the set of the things, rules that they agree to at the start of the game, they don't really adhere to. It's like playing a game where the bully on the playground changes the rules of the game just to suit whatever it actually suits them at the moment so that they could win the game. That is literally what is happening in the blockchain ecosystem, right?
That's interesting.
And yeah. So the third, I would say, is security. And we were talking about a building and files being driven down into the ground. And there have been so many instances of people just building a house without knowing, like, whether there's a pile underneath or not, because there are assumptions being made. And in the typical finance world, you have a bunch of things that are there, even though we might say to the finance world, like, you are doing various things. At least some parts of it, say the retail banking, to a large degree, plays the ball according to the rules that are being set for them, right? FCA would actually remove your ability to operate in the UK if you do anything funny, right?
Yeah.
So, there are some things there. And if you were to write a piece of software, it has to go through various things. Otherwise, that's fine. So there is PCI, payment card interface standard, that actually suggests to you, these are the cryptographic mechanisms, these are the security mechanisms there. None of this exists in blockchain. You could today, literally fork a protocol and create a new one like that. And you can look at Sushi Swap to actually understand what's happening, or YAM to understand what happens. YAM was a complete failure where you actually forked a protocol because they had no understanding of security. And this is one of the challenges we have in this ecosystem, that people don't understand. But whenever there's an existence of interdisciplinary thing that happens, it is easy for people to claim expertise. So if you go on LinkedIn and search for blockchain experts, you will see so many blockchain experts, and you only know the blockchain as an entity has been there so long. And some of them claim expertise in number of years more than the total amount of time that since Bitcoin paper was published, which was 2008 October 31st, right? So this is going to be pretty interesting. So this is a challenge.
Interesting. Okay, so maybe this is a good time to pivot to talking about R squared.
Sure.
Right. So
absolutely.
how does R squared kind of interact with these kind of problems that you're describing, and how are you positioned in relation to the current crypto and blockchain space?
Yeah. So what I recognized over the past few years was there is this massive cognitive dissonance that's actually happening in this ecosystem. When I say this cognitive dissonance, is like the signals that come out and the reality doesn't always match. And there probably is some value in having very high quality, high integrity, answers to questions being asked, right? So, if you were to think about, say, a protocol design, and you want somebody else to have a look at it and let you know what is actually going on, there are very few people who actually have the kind of expertise that's required, and B, very few people who actually shown throughout the last, close to a decade of time, that their opinion about something wouldn't be that influenced by the total number of zeros behind it, right? So I was looking for the skill set that I would require to run such a team. So I met a couple of my team members in the Stanford alum gathering in Paris. So when I went there for the Stanford Alumnus Conference, I was talking to one of them. He's an ex-Google data scientist. So, that's like, say, was describing, this is an interdisciplinary space. You need people. So that co-founder of mine is an economist who used to be a data scientist at Google. and he was involved in optimizing the revenue for Google from the ads, right? So a lot of the problems are very similar to what we have in blockchain. Then the other friend of mine with whom I have been working, he actually has the ability to do very good tech strategy and has very good ability to communicate what I describe as the humans that normally roam around the earth that make decisions, right?
Mm-hmm.
So he's he's a regular contributor to Forbes. He's a regular contributor to CNN. We've actually both together written pieces for CNN. So that is like a very important thing. So I could probably try communicate to you some very sophisticated mathematical thing, and the person who actually needs to decide needs to have that thing come to them in a way that they can make sense out of it, right?
Yeah.
And then there is the other piece that's missing, which is essentially somebody who actually have the skill and the ability to interact with the market on a continuous basis. So, my other friend who actually runs Bloom Water Capital, he joined us, and he was the person who had been interacting with the market on a continuous basis. You need to have this ability. And there are other friends of mine that I collaborate with, my PhD mates who I did PhD with in Royal Holloway, who have been doing research in cryptanalysis. And there are other people from Stanford who actually done research in graphs and things like that. So these are people who actually have deep expertise in doing what needs to be done. So I could put together a team that won't be easily swayed by the economics of the situation, and we literally consider ourselves as valuing integrity over anything else. So we really believe there is value to be had in the ecosystem for having high resolution, high fidelity answers to questions.
Yeah, some kind of proof of reputation almost.
Yeah, possibly. Yeah. Reputation is a heavily used word, which has been rather, how could I say, it's been taken out of context in blockchain in that sense. It's incredibly hard, and pretty much all our conversation has been about reputation, right? And it's very much it's the irony that you're asking me about that, and are asking me like what am I doing with the startup, where pretty much all of what we are trying to do. So we pretty much look at it this way. We actually are focused very much on a protocol sense, so from start to finish in that sense. As the team has the ability to actually do build, design, analyze protocol, simulate, or formally do verification. Or if it's ecosystem analysis, you build one, you come to us, then we will do all this. And we would a good number of us have very good training in a mathematical tool set, and have been researchers in cryptography. So we understand how we look at this, and we have been. It's not so often you get a chance to talk to people who were involved in building protocols after protocols. If you look at the top three out of two, I have in some sense been involved in and had the ability to influence decision making, and I've gone through the whole process. It is unlikely you'll be able to get one of them to come and give you some guidance on the next protocol you want to build. And so, and similarly, every member of my team has unique insights to building things, and they actually bring to the table the skill set that you can't get, in a complete sense at one place. That's
interesting. And and I guess it's like speaking to different people, right? So getting technical people to speak to more business savvy people, to like more political people, and this active translation that needs to happen in that. So I guess I've been hanging around like, the enterprise space in different communities within London. And one thing sometimes I hear is like, you don't have to understand like the internet to know how it, like, how to use it in this kind of like enterprise way. In the same way people say I feel you disagree.
I would have to disagree. Let me go back to our initial thinking problem, right? So let's assume this, right? Let's assume we don't know how automobiles work. We don't need to know how automobiles work. We trust automobiles. When you press your brake, you assume that brake stops. And if the brake fails, the manufacturer is liable, right? So whether you know or not, the question is that of trust and somebody verifying and doing that, right? Your assumption here is a problem. So what I am saying is like there are a bunch of assumptions being made, and not always all these assumptions are true. And I am saying there is some value to be had in actually saying, okay, if you want to get a sense of the truth about X, you could go to X or Y or Z and get an opinion. Where there is no ability for you, there is no enforcement, there is no police enforcing the fact, or there is no governmental agency enforcing your car.
Mm-hmm.
Your car has to go MOT test. If you don't pass the MOT test, you won't be allowed to go on the road. The argument is for you to drive, you don't need to know how the car works. Agree. Why? Because somebody else does the job for you. In a
Right, right.
blockchain world, in a decentralized world, because of the way the world works, it is up to you, yourself, because you don't trust anybody else but yourself, to understand exactly what's going on. If you have no idea of any of the things I described previously, you have only yourself to blame if you make massive mistakes.
That's yeah, that's true. And I guess this MOT would be kind of the smart contract version, right? And you're kind of
It's a
like
whole
trust.
bunch of it's a whole bunch of
Yeah.
things. So I actually gave it a talk in 2008, kind of summarizing some of the things. And in my DeFi thing and the previous piece I had on CNN, I actually alluded to this. There needs to be a whole bunch of responsibility and governance that
Mm-hmm.
you need to have. In a sense, like people shouldn't be just forking protocols and random and just deploying it and getting away with it, and they should have no downside in doing such things, because effectively what is happening is the world only have a limited amount of resources. You asked me what drives me, right? I told you
Mm-hmm.
I have this thinking of effective ultras, which is essentially, if you think about a set of all resources and think of two situations, there's two situations. Is one is a bunch of fraudsters run a bunch of fraud experiments, ruin the world of everything, and we are left with a world with no resources, no time, no nothing, right? We as a world have lots and lots of problems that we need to solve on a continuous basis. Right now we have COVID.
Mm-hmm.
There's an ongoing problem of hunger, poverty, racial injustice, then the meta problems of climate change. All of this is going on, and each of them, and then there's the other side. There's the threat of superintelligence hanging over human heads, right? There's a whole list of things that is hanging on. Some of them are existential threats, some are non-existential, and you need to solve all of them. And then you have only a bounded amount of time and resources available. If you have a whole bunch of people coming in and doing fraud and defrauding all the investors, what literally would happen is investors would be afraid to invest, and there will be no money left in an ecosystem to build anything that's of value, add a value. And in my mind, at least the way I see it, blockchain has the ability to solve some of the governance problems, provide transparency, provide the bridge between the centralized and the decentralized world, provide frameworks for governance for AI. There are lots of other things you could actually do. A lot of those things could be completely prevented if we actually have malicious acting. It's a tragedy of commons.
Mm-hmm.
Tragedy of commons that actually happened in the meltdown of the banks in 2007. It's going to happen in here as well, because it's like, you look at it and go, I am not going to do anything because it doesn't really affect me. But as an ecosystem, you are bounded. The total number of iteration a startup can have before it fails is bounded. It's like you can count it, right? Total
Mm-hmm.
amount of money you can have is bounded, is the amount of money raised. So all of this really, 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 we need to understand that these are all the things that we need to operate within as a framework. And if we ignore it, the peril
Mm-hmm.
is ours.
Do you think this kind of trust thing can be expanded? Do you think it should expand to all the things we trust? Or do you think blockchain is like, only for certain kind of problems and certain issues,
I
and there
think,
should be
yeah.
spaces where there are human trust kind of involved?
Oh, yeah, absolutely. I mean, I can give you lots of examples, right?
Yeah.
So the way I think about it is like, remember we were talking about humans in the loop and oracles and things like that. So, oracles in that sense is currently the mechanisms by which you actually interact between the physical world and the virtual world. Oracles are the prime suspect when it comes to how smart contracts operate. And if there are failures or protocols, that would result in failures of smart contracts, right? And that in turn it would be a failure of governance in that sense. Now the question is like, how do you actually incorporate this interaction between the human world and the smart contract world? And you also have this very, very interesting thing, which is legal structures, right? Legal structures is non-Boolean. Why do you think that one of the Supreme Court judges in US is a very important thing in the US and the world? The reason is it's not a computational thing. It's a very, very subjective thing. If there's 5-4, which is like 5 conservatives to 4 liberal, if that shifts to 6-3, literally that implies the odds that if something turns up and you need to actually make a decision, it becomes really skewed, because very high. So that's why it's very important. So this is what I'm kind of saying, that humans have been used to living in a world where we have a legal system which is very much non-Boolean and very contextual, and smart contracts is very Boolean and less contextual. So that is definitely, if you draw a Venn diagram of a set of all events, a larger set of events will be non-Boolean and a smaller set of events will be Boolean. And the place where it's very Boolean is very easy for smart contracts to actually do what they're supposed to do. Whereas in the non-Boolean space, which is like all the normal interactions between human, like, if you drive a car, you hit somebody, they got injured, whether you should be, charged for manslaughter is a very conditional thing. It depends on lots and lots of things. And then there's the question of ethics. Ethics is very much conditional. It's dependent on the person, it dependent on their cultural background, it dependent on where they are from. So, it very much depends. And that is where this is going to be very difficult. The smart contracts would find it very difficult. So we need to have this ability to incorporate into the decision-making metrics this input from human space.
That's interesting. And I imagine that's the kind of work that you're thinking along the lines of on your ethics of AI thing that you're kind of involved with, right?
Yes.
And do you think, you're kind of positing this, ethical problem as this relation between humans and technology?
Yeah.
Do you think it's also, what do you think about arguments that say that, certain technologies are colored with certain political kind of frameworks already? Like some people say, okay, Bitcoin is quite right wing. I also bought another book that someone said, like, maybe it's a bit communist in principle. So like, what do you think that there's certain ideologies behind technology?
Yeah. So I would say the following, right? The thing that I would say is technology on its own generally doesn't have, numbers don't actually have color in that sense. Okay. Numbers are an abstraction, right? What we try to represent that with is what we try to do, and that gives the context, and context is the king in this sense, right? So if you think about technology, you could probably say the basis of democracy is the ability for a human to have information arbitrage. Okay, let me rephrase that for you. So, I shall admit I am a spare time philosopher. I have a couple of papers published in philosophy. So I think of it as a philosophical problem where you look at democracy. Democracy assumes everybody has the same amount of information and has the same thinking process in place. Communism has a different thing. They think, the set of all humans are not good enough. We need to actually make the decisions for them. The tools could be the same, but the process could be different, right? So technology-wise, as far as I could see, technology has the ability to, accelerate progress in a civilization. It doesn't necessarily help in that sense, but it actually causes some interesting changes. One of the things I would say, and we kind of touched upon it briefly, but we didn't go into detail, is this price for doing certain things. So when I talked about cloud, I said, like, I was one of the people early on involved in creating the cloud and creating the frameworks around the cloud. The other side of the cloud conversation was the cost to compute come down significantly. There was a paper published by Google kind of describes this real ongoing challenge that we could capture in the world between, probably in a meta level, say China, which is a different governance paradigm and different sense about privacy. And the West, in some sense, mostly Europe, which has a better privacy characteristics. It's the fight between AI versus AI. What one sense of AI actually really preserves privacy, and or in some sense respects privacy. In the other sense, it doesn't give, nothing about privacy in that sense. You take every data you can get and you do that. This is only possible because the cost of compute has come down so low, because the capex versus opex conversation we were having in the start of the conversation. The cost has come so low that you could actually convert something which is an information arbitrage into real value. Okay, so Facebook wouldn't have existed if the cost of compute had been high. Google wouldn't have existed if the cost of compute was high. Twitter wouldn't have existed if the cost of compute was high. We are all able to have various services because the cost of compute has come down, because of Moore's law, as like the cost for a given chipset every 18 months comes down, right, by half. So essentially the compute power has gone up significantly. So essentially allows us to have compute at a much, much cheaper cost. And this allows us to actually have compute and still have an economic arbitrage.
How do you think, whenever I hear these kind of discussions happening, around blockchain, one maybe simple is I never hear, like, as an anthropologist, I never hear like human social relationships get talked about, and how people interact with these technology, and how how this will eventually come about in being useful for people.
It's a very interesting question you ask. So a couple of years ago in Berlin, there was this conference there's a conference called Rise of AI. And a friend of mine and me gave 2 talks. So the first talk was kind of mine, where I described how humans go from where we are right now to a hybrid situation, where essentially we go from being human and being able to interact with computational frameworks in such a way that, what Elon is kind of alluding to in a different sense. So it's like 2016, 2017, I can't remember when it was. Just Rise of AI, both Trent McCarthy, this CTO for Ocean Protocol, he gave a talk about this, the so-called emulation thing, or the simulation paradigm, where you can think of humans as being an emulation, right? So effectively, you could think of it this way. You could think of any framework and you think of a simulation. A simulation is almost indistinguishable from the real thing, right? If there were such a thing as a simulation happening, you probably might never be able to recognize. And this is like the thesis behind movies like Matrix, right? So you're plugged into a system as long as the system, because your interfaces to the world is very much neural impulses. The neural impulses, as long as this comes to you, you have no ability to differentiate whether let's put it this way: the difference between madness and sanity is the ability to kind of at least have an idea about where a signal originates. So this is how, in a meta level, what I would describe the whole challenge, right?
Yeah, it's interesting, simulation as the separation between reality and the code that describes reality. And then if that gap kind of breaks down, then it's kind of interesting as to what that happens.
Absolutely, yes.
What's on your roadmap going forward?
Yeah, so our roadmap is like, possibly 2 things. One is we really intend to build a framework that allows, people to evaluate their protocols in a much more rigorous sense. So I was kind of saying to you, a few years ago, that there's this thing called token engineering. So I've been somebody who has been actively helping people out. So at the first token engineering meetup in London, I gave the talk, and then globally I've been involved in 2018 when there was a thing, token engineering global meeting. I described this challenge and a skeptical view of token engineering, a cynical view of token engineering. I was kind of saying, if you build a protocol, and to have a protocol that actually has a certain characteristics, how do you verify them? How does it actually really work in the real world, right? So let me draw a comparison and give you what this means. Imagine you are a central banker. You have a monetary policy, right? You do a lot of things and to actually make sure that your policy, when it interacts with the real humans in the world, it doesn't really completely fail, right? In a token world, a protocol world, that doesn't exist. So I was kind of describing there are a whole bunch of things you need to do to actually make this as rigorous as possible. And we actually have some frameworks already in place, and we have been doing some validation. So that's why I said our combination of people, the skill set that we have, the skill set that drives Google, the skill set that actually, in between our team, there are two people who broke SSL and IPsec. IPsec got broken by me, and the other teammate actually who's just joining us very soon. He had an attack on SSL. So we've had a lot of expertise in just breaking protocols and building protocols and understanding things in a way that we could add a lot more rigor, right? In a truly multidisciplinary sense. That's one thing we really want to do in that sense. And kind of really, the very least, provide the framework that allows, in a broader sense, for protocols in the DeFi sense to be actually, some sense, validated, to have a better ecosystems to be built. That's like an immediate thing. Going forward, we might do much more larger things. We might probably look at some of the problems zero knowledge space and see if some of the components that are missing in the ecosystem, should we go and build them? I mean, those could be things that we might end up doing, but immediately, the most immediate need that we see, and that has been really something that's being, making me uncomfortable, is a set of practices by a set of people who really don't understand a lot of the things in this space. Like, people who walk around and talk about token engineering who don't understand cryptography, to me, is a massive problem. If this is like this, it's like, if you want to do surgery, you need to do anatomy, right? And cryptoeconomics is the basis of token engineering, right? So if you're going to say to me, and half of cryptoeconomics is cryptography, right? So, I guess you get where I'm going. Like, if you don't understand half of it, you're going to say to me that you understand it fully and you're able to go do surgery. I go, no, right? And in that sense, and the challenge is problem, right? The real challenge is the ecosystem is like, it's like we have this same situation as we have in a cardiac surgery. You take a patient, you open their heart, you disconnect the human from the heart, you connect it to a heart-lung machine, you do the surgery, you put it back. When you put it back, if it doesn't restart, you're done, your history. It's a one-way function, right? So to normalize the risk, you would look for risk normalized outcome of surgeries of cardiac surgeons. Okay, not the degrees, not the papers they publish, not the bullshit they're able to go give talks, right? But as their ability in real world as to how many patients survive, right? And the people who walk around and talk about token engineering are people who have real dead bodies, coffins they have actually hidden in other places. I am willing to stand out and say to everybody, look, my name has been there in all your places. I can't lie to you. And I have places in the top ones, okay? And I'm saying to you, you need to do the right thing. Maybe I didn't actually make all the money in building all those, because that wasn't the thing that drove me. What really drove me was this bigger problem we as humanity have. And we should rather be focusing on that rather than, being cardiac surgeons who actually do lots of positions, publish books, give talks, but don't even know what anatomy of thoracic cavity is, okay? So these are the cardiac surgeons, the fake cardiac surgeons, the quacks of the world. These are the token engineers of the world. Complete and utter fictitious people who really don't. There are very few exceptions. There are some, there are some people who really understand this thing. So that is, for example, Taran Chetra, right? He understands finance, he understands cryptography. He can articulate things in a regular manner, and he could actually do things. There are very few of them, right? And that's the challenge of humanity right now. We have so many protocols coming out. There are not enough people. It is like you having a disease that we have in humanity, and we don't have enough doctors to treat. So all the patients who come with the disease are really destined to die, literally, in that sense.
And I think for me, it's just a personal thing that I'm interested in writing about at the moment is kind of the idea, this community that is bringing these ideas forward, right? That are kind of the phrase community gets used quite a lot, which I find quite interesting. And this community is part of like what idea comes about. And you're saying sometimes there are people within this community that don't necessarily perhaps understand the whole picture, like you're saying, right? Understand the cryptographic element and the other half as well.
I am not
And
saying, I'm pointing to the
yeah,
facts, right? I
yeah,
am drawing conclusion based on facts.
yeah.
The fact is we can do numbers. Let's do the numbers, right? So
Hmm.
total number of people in this ecosystem who have actually spent time doing research in cryptography,
Yeah.
incredibly small. You could look
Mhm.
at them, total set of people, and people who say they are doing token engineering. Look at the publications they have done. Look at the labs they worked on, and look at
Mhm.
their master's thesis, their PhD thesis, right? And you can see that they don't have any credential anywhere, either in
Mhm.
published papers or in their research or in the academic stuff of any of
Mhm.
this. And
Mhm.
suddenly, this is the question we were asking from the real start, the question about
Mhm.
reputation, which you brought about, right?
Mhm.
Proof of work, right? Essentially, when I turn up and you ask me what's your
Mhm.
credential, I say I
Mhm.
have 20 years of doing this. My master's thesis
Mm.
was on taxonomy because
Yeah.
my master supervisor, Stephen Galbraith, I
Mhm.
say these are my papers. I worked on Cryptography Research Institute and ISI. I worked in Microsoft
Mhm.
Research. My papers are listed there. I am actually
Mhm.
providing you proof of work. I'm actually giving you your ability to verify in a
Mhm.
passive or active sense all the claims that I make. None of the
Mm.
people who turn up, or you can actually see what fraction of the people in this ecosystem actually
Mm.
provide you with the proof. And that is a problem. There is no correlation between the claim and the proof. If you make, what do I call unconventional claims, you need
Mm.
to provide unconventional proofs, right? And
Mhm.
unfortunately, when, say, for example, the ICO world, that was a challenge. And I
Mhm.
see this is a problem in two senses. This is this cognitive dissonance between the distributed world and the real world, right? And the map failing. And at the same time, even in the real world, there's arbitrage to be had. In a sense, like if you could make a claim that you are better than what you are, there's a larger piece of the pie that you could capture and signal other people. And this is essentially causing a herd behavior. The herd
Mm.
behavior is like you only want to be with the person who has a larger amount of resources,
Right.
not the
Yeah.
ethical value, not the
Mhm.
intellectual rigor, not the expertise. And this is a big problem for blockchain. Instead of actually, if humanity were to get the most value out of blockchain, we
Mhm.
really need to respect the fact that governance can never be created by a set of thieves. It's very unlikely
Mhm.
that would happen, right? There
Yeah.
is there need to be some amount of transparency, some amount of trust, some amount of ethics that need to go into it. If there is no ethics, there is no transparency, there is no governance, it's very unlikely that we will end up with an ecosystem that is capable of providing what everybody claims that they are trying to do. Provide access to banking for the unbanked,
Mhm.
providing privacy and access to data for the people. If these
Mhm.
people are worse than Facebook, how are we supposed to trust them? At least,
Yeah.
most of the people in the Facebook are held liable for
Mhm.
SEC, other legal entities.
Mhm.
In EU, you actually had fines on Google, right? All of those
Mhm.
things. Very few of the crypto protocols have actually been fined. Very few of them actually have gone to jail. Very few of them actually have been shamed. The behaviors of all the crypto leaders are now being put on the microscope, right? A lot of the things are missing. So this is a challenge. You're absolutely right
Yeah.
in pointing out to the challenge.
Yeah, that's interesting. Yeah, and I mean, this is just my, yeah, again, my perspective that, the kind of obsession with like profit and money, I guess,
Yeah,
kind of brings kind
drives.
of players. And what I find interesting, what shifted in my understanding of the community within the space, there was this, emphasis on like openness and openness within this community, right? Which is comes from like coding, kind of like GitHub kind of culture,
I,
and
I think
that's
I
kind of
think that's an
shifted.
assumption that everybody takes for granted. I'm going to
Yeah.
challenge somebody because
Mm.
this goes back to my thesis of building this thing, right?
Yeah.
I would challenge how many people in this
Mm.
community understand that why the choice of curves are important and which curve to choose if they were asked, right?
Mm.
So essentially, pretty much all of this, most of this,
Mhm.
is based on elliptic curves.
Mhm.
Very few of them really understand any of the crap. And going back
Mm.
to this paradigm question where you drive a car and
Mhm.
you know the drive,
Mm.
right? So, everything actually has significant implications, right? And I was saying between me
Yeah.
and my other friend, we are actually
No.
broken two protocols, right? We've
Yeah.
actually seen how protocols work and how, knowing is very different from implementing. Okay.
Yeah.
It's like, how do you actually learn how to swim? By learning reading a book. So this is how
Well, true.
security engineering really means. Okay. It really requires people who know how the hell to build. And that's why NSA pay and GCSQ pay a lot, hire a lot of people to do lots of things, and they are kept after and looked after pretty well, right? That skill is really valuable. Okay, there is a real value for the skill in the open market. It is unlikely, unless the blockchain ecosystem is willing to pay the same amount of money to attract the same kind of talent, we will be able to provide the kind of security we have on the normal protocols.
I mean, so
Simple.
what if someone comes to you, Anish, and says like, okay, I'm just going to hire a CTO. Like, I'm a business person.
Hmm.
Like, blockchain sounds interesting. I kind of understand it. I'm just going to hire this CTO who's just going to take care of the technical stuff for me. And I'm going to have this like half an hour or an hour Zoom call with them. And they're going to like tell me what's possible, what's not possible. I mean, do you think like there needs to be one person that understands how like all the cryptography
It's a
stuff
very
works?
interesting problem that you're proposing to me. You kind of asking me, does there exist an oracle in human form that can actually answer a set of all questions? Given I'm a Bayesian, I would say, based on the data I've seen, the prior probabilities, it is pretty unlikely, right? It is more like you asking me, Anish, what are the odds that I would win a lottery, right? We can do the numbers for a lottery for blockchain, right? Let's assume set of all people that actually understand this tech, okay? And then you claim to understand this tech. Then let's try, drawing the Venn diagram. How many of them really understand economics? How many of them really understand cryptography? How many of them really understand game theoretic aspects of it? How many of them understand, social and legal aspects of it? What we are kind of saying, if somebody were to answer all the questions, the assumption is that that person is the intersection of all the different diagrams, right? All the Venn diagrams in that sense, all the circles. And that population will be very, very tiny. It's a product of probabilities. It's a power law distribution. So the larger the number of criteria you have, lesser the number of people you have, and the lesser the chances that people have that level of competency. So the likelihood that if I take a lottery, I will win, we know is very low. And similarly, the odds that you actually find a CTO, the chance that he or she will be able to give you the answer is very, very low, because the total number of people who probably can capably answer those questions at the level you want is incredibly small. And the chances that you might be able to find one of them, because they are so precious that, there's an arbitrage that's going on for their attention. There's an attention arbitrage. So your chances of ever getting get what I'm going, right?
Yeah. And yeah, and finding that one. So rather than finding that one person, can't we let these different Venn diagrams still be in conversations rather than like having this one person? And maybe that's a skill of a business person, right? To be like, put different people in conversation.
Part of what we've been trying to do is exactly that. That is one of the part of the reasoning behind how we got our team together, right? Because I know a whole bunch of things, but I know for a fact I don't know, right? This is a problem we have in the blockchain space, Dunning-Kruger syndrome, right? The fact that you don't know that you don't know. And that's like a super important thing to know, that you don't know, And then you can go and ask people. The problem in the blockchain space is pretty much because you don't know. Like, I'm pretty sure if you ask, 100 people, can you explain to me, how do you know a number of points on an elliptic curve? The chances that probably 10 of them will be able to give an answer. And the more you go into it, you will end up with, and this is like the basis. Like, so this is like, for anything else, it will be like, if you don't know this, you shouldn't practice, right? This is like, if you want to practice medicine, you need to be able to recognize the pulse, right? You know what I'm saying, right? If you can't recognize whether the person is dead or alive, what's the point of being a doctor? So this is the kind of challenge we have here, right? It's like the level of Dunning-Kruger syndrome, the prevalence of Dunning-Kruger syndrome in this ecosystem is so high that it's very hard for us to actually, find somebody randomly and, expect them to give us the kind of answers that we want. So, we could literally say to somebody, okay, this is what happened. And the answers that was given to us was very good, but, that's not going to happen. So, it is not going to happen.
Interesting. Yeah. And I like the thing you said about active translation between different parties and different expertise and different knowledges. And I think that's it. And also uncertainty is it's also the title of my PhD, what I do, like uncertainty and possibility. So that's what I look at theoretically, how
Yeah.
people deal with like the uncertainty within the space, how, things that they don't know and how they deal with it, which I think is the most fascinating thing for me. Like, you know, there's this future coming, and how do our people going to interact with it is kind of what, anyway, I look at that kind of social stuff. It's
Yeah.
super interesting for me anyway. Okay, cool. Thanks, Anish.